In today's video, we'll discuss about Chemistry Paper 1, MCQ Paper 2017 May June Variant is 11 and the subject code is 9701. So, in today's video, we will mainly discuss from question 1 to question 30 and the type of question, that is question 31 to question 40. This type of question is not currently in our syllabus, so we would just avoid them. 1. Which molecule contains 6 bonding electrons? So which molecule contains 6 bonding electrons? So in C2H4, if we draw the structure, then this is the structure, and 1, 2, 3, 4, 5, 6. So 6 bond, and each bond consists of 2 electrons. That means in total we have 12 electrons. So we need 6 electrons or 6 bonding electrons. Then for SH2, sulfur and hydrogen, so in we have 2 bonds, that means 4 electrons are being shared. Then NCl3, 1, 2, 3, so 3 bond, that means 6 electrons are shared, that is 6 bonding electrons, so the answer is C. Then for SF6, so SF6, and here 1, 2, 3, 4, 5, 6, so 6 bonds, that means 12 bonding electrons. So since there is 12 bonding electrons, so this is wrong. So the correct answer is C. Number 2. The mass spectrum of a sample of lithium shows that it contains 2 isotopes, lithium-6 and lithium-7. The isotopic abundance are shown in the table. So this is the isotopic abundance, that is for 6 the percentage is given and for 7 the percentage is given. What is the relative atomic mass of the sample of lithium given to 3 significant figures? So what is the relative atomic mass? So to calculate the relative atomic mass, first of all we have to find the sum of the total percentage. So in total the total is 100%. So since the percentage is 100%, so percentage of 6 into the 6 by 100 plus percentage of 7 into 7 by 100. So in total we get the answer as 6.9258, that is approximately 6.93. So the answer is D. 3. A sports medal has a total surface area of 150 cm square. It is evenly coated with silver. By electrolysis, its mass increases by 0.216 gram. How many atoms of silver were deposited per centimeter square on the surface of this medal? So we need to find the number of atoms in per centimeter square. That means in 150 centimeter square there is 0.216 gram, that is 0.216 gram in 150 centimeter square. So for 1 centimeter square, 0.216 by 150, so this much gram. So we know the mass in gram, and since it is silver, so we need to find the number of moles of silver. There is number of moles is equal to mass in grams by AR or MR. So mass in grams by AR of silver is 107.9. So 107.9. So the number of moles comes to be 1.33 to the power negative 5. So this is the number of moles of silver. Now we need to find the atoms. So to find the atoms, that is number of atoms is equal to number of moles into 6.02 into 10 to the power 23. That is Avogadro's constant. So number of moles into Avogadro's constant. So after multiplying, we get the answer as 8.0 into 10 to the power 18. That is this much atoms. So the number of atom is 8.0 into 10 to the power 18. Number 4. Which property of an atom does not affect its first ionization energy? So atomic radius. As the atomic radius increases, the valence electrons move further from the nucleus, and so the first ionization energy decreases. Then the number of electron shell. So as the number of electron shell increases, the electrons move further from the nucleus. As the electrons move further from the nucleus, so the first ionization energy decreases. Then number of protons. If the number of protons increases, that means more nuclear attraction, therefore the first ionization energy increases. But the number of neutrons has no effect on the first ionization energy, so the correct answer is C, that is the number of neutrons has no effect. Number 5. Which molecule has the largest overall dipole? So hydrogen has no dipole, while CH3 has also no dipole, and so this is a symmetrical molecule with no dipole. Then CH3 has no dipole, while oxygen is slightly negative charge, so there is some dipole, so the answer could be B. Then in option C, oxygen and chlorine are slightly negative charge, so there is a overall dipole, but since the molecule is symmetrical, so there is no overall dipole. Then CH3 has no dipole and Cl is slightly negative charge, so this molecule is also symmetrical, that cancels the dipole, so there is no dipole. So the correct answer that has the largest overall dipole is in option B. Number 6. The complete combustion of 2 mole of straight chain of alkane produces 400 dm cube of carbon dioxide measured at 301 Kelvin and 110 Pascal. Carbon dioxide can be assumed to behave as an ideal gas. Under these conditions, what is the formula of the straight chain alkane? So we need to find the formula of this alkane. So first of all, as it is mentioned that carbon dioxide behaves as an ideal gas, so we can use the formula Pp is equal to nRT to find the number of moles of carbon dioxide. There is number of moles is equal to Pv by RT, where we have given the value of pressure. R is 8.31, that is the constant, and temperature is 301 Kelvin, so it is given in Kelvin, so we do not need to simplify it. But the volume is in dm cube, and we know that 1 meter is equal to 10 decimeter, so 1 meter cube is equal to 1000 dm cube, or we need to convert dm cube to meter cube, so 1 dm cube is equal to 1 by 1000 meter cube. So we just convert 400 dm cube to meter cube and find the number of moles, that is 15.99 mole, that is approximately 16 moles of carbon dioxide. So since there is 16 moles of carbon dioxide, that means there is 16 carbon on the product. So since there is 16 carbon on the product, so we must need 16 carbon on the reactant. And as we can see that 2 moles of the alkane reacted, so since there is 2 mole reacted, so 2 mole of alkane, that means the correct answer should be A. That because for 2 moles, if we write the equation, then CH818, so as we can see that it is balanced, there is 16 carbon on the left hand side and 16 carbon on the right, so the correct answer is A. And it is alkane, that is CnH twice N plus 2, so this confirms this configuration, so the correct answer is A. Number 7. Which expression gives the standard enthalpy change of combustion of methane? So methane reacts with oxygen to form carbon dioxide and water. If we write the balance equation, then methane is CH4, reacts with oxygen to form carbon dioxide and water. So one carbon is balanced. Then there is 4 hydrogen, so we place 2. So 4 hydrogen, and the number of oxygen is 2 plus 2, that is 4. So we place 2. So this is the overall balanced equation. And for this balanced equation, we need to find the enthalpy change of combustion, that is delta Hc. So enthalpy change of combustion, so we have all given the enthalpy change of formation, so we need the enthalpy change of formation of methane, then enthalpy change of carbon dioxide, and 2 into enthalpy change of water, since there is 2 moles of water and oxygen is in gaseous state, so there is no need to the formation of oxygen, and it is also not given. So delta H of combustion would be, that is the arrow on this side is equal to the arrow on this side. That is, what is the arrow on this side? That is the enthalpy change of formation of carbon dioxide plus 2 into enthalpy change of formation of water minus enthalpy change of formation of methane. Since this is in this side, so if we place the formation of methane on the other side, we need to place a minus sign. So the correct answer is D. In question number 8, which oxidation state is shown by chlorine in each of these following ions? So the oxidation state of chlorine in ClO minus, so we refer Cl as X. So X plus the oxidation state of oxygen is negative 2 is equal to negative 1. So X comes to be, after solving, it comes to be positive 1, positive 1. Then ClO3 minus, so we refer Cl as X. Then 3 oxygen, so oxygen has the oxidation state of negative 2, so negative 6. And if you place this negative 6 on this side, then plus 6. So the oxidation state of Cl comes to be plus 5. So plus 5. So the correct answer is C. And the oxidation state of chlorine in Cl minus is obviously negative 1. So we have given this balanced equation. What are the values of A and C in the balanced chemical equation? So we need to find the value of A and C. And here we have given the options. So first of all, we have to find the oxidation state, that is the change in oxidation state. So for manganese, its oxidation state in MnO4 2 minus, so negative 8. So manganese has oxidation state of positive 6. Then here oxygen is negative 2 into 4, that is negative 8, and the negative 8 goes to the side, so plus 7. So manganese plus 7, and here it is plus 4. So we can see that manganese changes from plus 6 to plus 7 and plus 4. So if you just write the equation for oxidation and reduction, that is first of all the equation for oxidation, that is MnO4 minus, that is 2 minus, changes to MnO4 minus. So this is the equation for the oxidation, that is MnO4 2 minus changes to MnO4 minus, and for the second equation MnO4 2 minus, it again changes from plus 6 to plus 4, that is MnO2. So in each of this molecule, that first of all we have written the equation or the equation for the oxidation and reduction. Then we have to balance the number of oxygen. So here we can see that 4 oxygen, so it is balanced. Then here it is 4 oxygen and 2 oxygen. So we need to balance the number of oxygen by placing water. That means here we need 2 oxygen to balance this equation. That is H2O, 4 oxygen, 2 oxygen, so 2 water. So in total there is 4 oxygen on the right and left hand side. Then we have to balance the number of moles of hydrogen ion. So there is no hydrogen ion, while there is 4 hydrogen ion on the product side. So we have to place 4H plus on the reactant side to balance the number of hydrogen. So the overall equation is balanced, but now we need to balance the number of electrons. So in total there is 2 minus electron and there is 1 minus. So 2 minus and 1 minus, so we have to place an electron. So overall charge is balanced, and for this equation 2 electrons. So first of all we erase this. So 2 electrons and 4H plus. That means in total the charge is plus 2. And here the charge is 0. So to balance this plus 2 charge, we place 2E minus. So as we can see that plus 2 and negative 2E minus balances each other out. Now we need to balance the number of electrons in both the equation. So here there is 2 electrons. Now we need to place 2 electrons on this side. So we multiply this equation by 2. So 2MnO4 2 minus changes to 2MnO4 minus plus 2E minus. So if we write the overall equation, then 2MnO4 2 minus, that is we need to add the reactants on this side and the product on this side. So 2MnO4 minus and 1MnO4 minus, so 3MnO4 minus, and the electrons cancel each other out. Then 4H plus changes to 2MnO4 minus and 1MnO2. 2MnO4 minus plus MnO2 plus 2H2O. So MnO4 2 minus, MnO4 2 minus, and MnO4 minus. So the ratio of A to C is 3:2. So the ratio is 3:2. So the correct answer is B. Here we have given the equation and we need to find the value of Kp. So Kp is the partial pressure of product by partial pressure of reactant. So partial pressure of product, that is CH3OH. So CH3OH, then partial pressure of reactant, that is partial pressure of hydrogen, and since there is 2 moles of hydrogen, so the partial pressure to the power 2, that is partial pressure to the power 2, and partial pressure of carbon monoxide. So partial pressure of carbon monoxide. So the correct answer is C. 11. When 4 grams of powdered calcium carbonate MR100 were added to 100 cm cube of 0.1 mole per dm cube of hydrochloric acid, the volume of carbon dioxide produced and recorded. So the volume of carbon dioxide produced was recorded. So this is the increase in time. So time increases linearly, while the total increase in volume, as we can see that the increase in volume decreases over time until it becomes a constant value. That is, the reaction ends. Which row gives the correct explanation about this result? Why the rate of the reaction changes with time and why the reaction stops. So why the rate of the reaction changes with time? As we can see that the rate of the reaction decreases with time. So obviously fewer collision between the reactant molecules and fewer collision between the reacting molecules. Since the fewer collision occurs, So the rate of the reaction or the speed of the reaction decreases. And why this occurs? So to find why this occurs, we need to find the number of moles. There is a number of moles of calcium carbonate. So we have given the mass in grams and the MR of calcium carbonate is 100. So we get the number of moles of calcium carbonate and the number of moles of hydrochloric acid is volume into concentration, and we must convert the volume to dm cube. So we get this much moles of hydrochloric acid, and according to the balanced equation, 1 mole of calcium carbonate reacts with 2 moles of hydrochloric acid. So 2 moles of hydrochloric acid, that is 0.02. As we can see that 0.04 mole of calcium carbonate reacts with 0.02 mole of hydrochloric acid. So as we can see that hydrochloric acid is a limiting reactant. So hydrochloric acid is being used up. So the correct answer is B. Number 12. Why is the second ionization energy of sodium larger than the second ionization energy of magnesium? So for sodium, according to the options, the attraction between the nucleus and the outer electron is greater in sodium than in magnesium, positive ion. So the attraction between the nucleus and the outer electron is greater in sodium positive ion than compared to magnesium positive ion. So for sodium positive ion, that is sodium positive ion and magnesium positive ion. So for these positive ions, sodium loses an electron and its outer electron is now in 2p6, and magnesium positive ion has an outer electron in 3s1. So as we can see that the outer electron in sodium positive ion is in the inner shell, so more attraction by the nucleus since the number of cells are reduced, and so greater nuclear attraction. So yes, the attraction increases, and due to this increase in attraction, the second ionization energy also increases. Therefore the answer is A. The nuclear charge of sodium positive ion is greater than the nuclear charge of magnesium positive ion. This statement is wrong because sodium contains 11 protons while magnesium contains 12 protons. Since magnesium has more protons, so it has greater nuclear charge. The outer electron of sodium positive ion is more shielded than the outer electron of magnesium positive ion. So as we can see that the outer electron of sodium positive ion is in 2p6 while the outer electron of magnesium positive ion is in 3s1. So the outer electron of magnesium positive ion is more shielded. So magnesium positive ion is more shielded. The outer electron of magnesium positive ion is more shielded. Magnesium positive ion is more shielded than compared to sodium positive ion. Therefore this statement is wrong. Then the outer electron of sodium is in the same orbital as the outer electron of magnesium. So the outer electron of sodium and magnesium are both in the 3s orbital. So this statement is true, but this statement has nothing to do with the ionization energy. Therefore this statement is also wrong for this option. So the correct statement is A. Question number 13. Which graph correctly shows the relative melting point of element magnesium, aluminium, silicon and phosphorus plotted against their relative electronegativity? So as we go across the period, that is from magnesium, aluminium, silicon, the electronegativity increases. So phosphorus has the highest electronegativity. There is the highest electronegativity. This is wrong. Then electronegativity, this is wrong. Phosphorus has the highest electronegativity. Then melting point. So for the melting point graph, magnesium, then aluminium, then silicon has the highest melting point, then phosphorus, then sulfur, then chlorine has the lowest. So yes, this statement is correct. Number 14. An excess of magnesium oxide is shaken with water. The resulting solution is filtered in test tube X. An excess of barium oxide is shaken with water. The resulting mixture is filtered into test tube Y. Which oxide reacts more readily with water and which filtered has the lowest pH? So which oxide reacts more readily with water? So we know that down the group reactivity increases and also the solubility of hydroxide increases. So yes, barium oxide is more soluble or more reactive with water. So barium oxide, and the test tube with filtered of lower pH. So for lower pH, we know that barium oxide reacts with water to form barium hydroxide. Similarly, magnesium oxide reacts with water to form magnesium hydroxide. And down the group, since down the group hydroxides are more soluble, so barium hydroxide is more alkaline than compared to magnesium hydroxide. So barium hydroxide is more alkaline. That means if you compare, magnesium oxide is more acidic or magnesium hydroxide is more acidic. So magnesium hydroxide is more acidic. That's why it has a lower pH. So it is in test tube X. So the answer is A. Question number 15. Sample of magnesium carbonate are placed in crucible RNS. The sample in crucible R is heated until there is no further loss in mass and then allowed to cool. The sample in crucible S is left unheated. Dilute hydrochloric acid is then added to both crucibles. On adding the dilute hydrochloric acid, which observations are correct? So in R and S. So basically, the sample in crucible R is heated until there is no change in mass. That means magnesium carbonate is heated to form magnesium oxide and carbon dioxide is released in the atmosphere. That means in crucible R, we mainly have magnesium oxide. That is magnesium oxide. And crucible S is left unchanged. So magnesium carbonate. Then dilute hydrochloric acid is added. So by adding dilute hydrochloric acid to magnesium oxide, magnesium chloride and water is formed. That is dilute HCl reacts with magnesium oxide to form magnesium chloride and water, so no gas is formed. While with magnesium carbonate reacts with dilute hydrochloric acid to form magnesium chloride, carbon dioxide and water. So as carbon dioxide gas is formed, so the answer is C. Question number 16. Which statement about nitrogen or its compound is correct? In the Haber process, the temperature is kept high to give a good equilibrium yield of ammonia. So for the Haber process, nitrogen reacts with hydrogen to form ammonia and the forward reaction is exothermic. So the forward reaction is exothermic, that means increasing the temperature decreases the yield of ammonia. Therefore, as the temperature is kept high, so the equilibrium yield is not good. The equilibrium yield is less. So the yield is less, therefore this statement is wrong. Then nitrogen gas is unreactive because of the strong nitrogen-nitrogen double bond. This statement is wrong because nitrogen-nitrogen triple bond is present. Then in option D, the formula of ammonium sulfate is this formula. This is wrong because the formula of ammonium sulfate is this formula. Therefore, this statement is wrong. So the correct statement would be C, that nitrogen monoxide will react with carbon monoxide under the case nitrogen monoxide reacts with carbon monoxide to form nitrogen and carbon dioxide. So the statement C is in question number 17. When concentrated sulfuric acid reacts with sodium iodide, the products include sulfur, iodine, H2S, and sulfur dioxide. Which statement is correct? Hydrogen sulfide is the product of the reduction reaction. So basically this reaction occurs that sodium iodide reacts with sulfuric acid to form NaHSO4 and HI. Then HI then reacts with sulfuric acid to form iodine, sulfur dioxide and water. Also HI reacts with sulfuric acid to form iodine, H2S and water. Also HI reacts with sulfuric acid to form iodine, sulfur and water. So for H2S, we can see that the oxidation state of sulfur is negative. So the oxidation state of sulfur is negative 2. While for sulfuric acid, the oxidation state of sulfur is +6. That is negative 2, positive 2 and negative 8, so +6. So as we can see that sulfur changes from +6 to negative 2, therefore it is reduced. So H2S is the product of the reduction reaction. Yes, this statement is correct. Then iodide ions are stronger oxidizing agent than sulfate ion. So for this reaction, iodide ion and sulfate ion. Okay, so iodide and sulfate, suppose this reaction, then iodide and sulfate. So as we can see that iodide ion changes to iodine, that means -1 to 0. Therefore it is oxidized, while sulfate changes from +6 to +4. Therefore it is reduced. Since iodide ions are oxidized, therefore it is a beta reducing agent. So as iodide ions are oxidized, so it is a beta reducing agent, not oxidizing agent. Then sulfur atoms from sulfuric acid are both oxidized and reduced. This statement is also wrong because for all of this reaction, sulfur atom from sulfuric acid changes from +6 to 4, -2 and 0 oxidation state. Therefore, they all are reduced. So the sulfur atoms are only reduced. Then sulfur atom from sulfuric acid are oxidized to form sulfur dioxide. This statement is also wrong because from sulfuric acid, that is +6, it changes from +4. Therefore, it is reduced. So the correct answer is number 18. A solution of sodium hydroxide reacts with 3 mole of chlorine. So sodium hydroxide reacts with 3 mole of chlorine. So chlorine gas under the conditions the reaction produces 5 moles of sodium chloride, so 5 moles of sodium chloride and 1 mole of X, the only other chlorine containing product. What is the formula of X? And you should have to remember that the other product, that is NaOH, reacts with chlorine to form NaCl and NaClO3. So this is 1 mole and NaCl is 5 mole while chlorine is 3 mole and sodium hydroxide is 6 mole. So this is the balanced equation for this reaction, and this occurs when sodium hydroxide is hot. And if suppose if sodium hydroxide is cold, that is sodium hydroxide reacts with chlorine to form NaCl, NaClO and water. So this is the overall equation. So what is product X? So from this reaction the product X is NaClO3. Number 19. The redox reactions are common in chemistry of group 17. Which statement is correct? So bromide ions will reduce chlorine but not iodine. So for this, first of all, fluorine, chlorine, bromine, iodine and acetylene, these are group 7 elements. So reactivity decreases down the group. So down the group reactivity decreases, and down the group the atoms become less reduced or more oxidized. Since it is more oxidized, so therefore it is a better reducing agent, and since it is less reduced, so it is a poor oxidizing agent. So, and you also have to remember that a more reactive halogen can displace a less reactive halogen from a salt solution. So a more reactive halogen can displace a less reactive halogen from a salt solution. And in this reaction, chlorine is the most reactive halogen. So it can displace a less reactive halogen, that is the bromide, from a salt solution, but not iodine. So this statement is correct. Then chlorine will oxidize bromide ion, but not iodide ion. Chlorine will oxidize both bromide ion as well as iodide ion. Therefore, this statement is wrong. As this is a more reactive halogen, so it can displace a less reactive halogen from a salt solution. Then F2, F2 is the weakest oxidizing agent out of F2, Cl2, Br2 and I2. So for this statement, so fluorine is more reduced. So it is more reduced. That's why it is a good oxidizing agent. Since it is reduced, therefore it is oxidizing agent. So it is not the weakest, it is the strongest oxidizing agent. Then iodide ions are the weakest reducing agent. This statement is also wrong because iodide ions are less reduced. Since it is less reduced, so it is more oxidized, and since it is more oxidized, so it is a better reducing agent. Number 20. Structural isomerism and stereoisomerism should be considered when answering this question. Each of the following carbonyl compounds is reacted with NaBH4. So NaBH4 is the reducing agent and LiLH4 is also the reducing agent, but NaBH4 cannot reduce carboxylic acid while LiLH4 can reduce carboxylic acid. The product of each reaction is heated with Al2O3 at 600 degrees centigrade. So aluminium oxide at heat, in presence of heat, convert alcohol to alkene, generating one product or mixture of isomers. Which carbonyl compound will produce most isomers? So among these compounds, which compound will produce most isomers? So first of all, we need to draw each of the structures. So butanol, so it is an aldehyde, so COH and butanol, that means METH, ETH, prop, but, 4 carbon and aldehyde. So this is butanol. Then butanon, so butanon is a ketone. So butanon, that means 4 carbon ketone. So this is the 4 carbon ketone. Then pentane so pentane, that means 5 carbon. So 5 carbon and one means it is a ketone. So pentane 1, 2, 3, pentane 3 on. Then propanon. So propanon, that means 3 carbon ketone. So we have drawn the structure. Then we have given that the first instruction is that they react with NaBH4. So NaBH4 reduces all of these substances. So aldehyde is reduced to alcohol. Then ketone is also reduced to alcohol, and here there is a ketone, so it is also reduced to alcohol, and this ketone is also reduced to alcohol. So this is the product after reaction with NaBH4. Then the remaining product reacts with Al2O3 at 600 degrees centigrade or at high temperature. So Al2O3 converts alcohol to alkene. So this alcohol is converted to alkene. Then this alcohol is converted to alkene, and there is two possibility that the hydrogen is removed, OH is removed from this carbon, and hydrogen is removed from either this carbon or this carbon. So double bond can form in this place, that is this double bond, or either in this place, that is this double bond. So there is two structures. Then this alcohol, so this is also the same. The hydrogen is removed from either this carbon or this carbon, so two product is formed. Then again, for this alcohol, hydrogen is removed from either this carbon or this carbon, so again two product is formed. And so these are the remaining product, and we need to find that which product produces most isomers. So for this compound, there is only one isomer. Then for the second compound, so for the second compound, so as this double bond carbon is bonded to this carbon is bonded to the same group, so there is only one isomer. Then for this carbon, these double bonded carbon atoms are attached to two different groups, so two isomers are produced. That means cis trans isomer occurs. Then for this structure, so CH3CH and CH3CH is same, and this structure, that is CH2CH3, CH2CH3 are the same. Therefore, this is the only one product, and for this product, we can see that cis trans isomer occurs because the double bonded carbon is attached to two different groups. So two isomers. Then again, for this structure, we can see that this structure is same as this structure, and the double bonded carbon is not attached to two different groups, so there is only one isomer. So which produces most isomer? The last one produces one, first one also produces one, so they cancel. Then for the third one, it produces two isomer, while for the second one it produces three isomer. So the correct answer is B, as it produces three isomer. 21, the drug cortisone has the formula shown. So this is the formula. In addition to those chiral centers marked by an asterisk, how many other chiral centers are present in the cortisone molecule? So the chiral carbon is the carbon that is attached to four different groups, and it produces optical isomerism. So we need to find which carbon is chiral. That means which carbon is attached to four different groups. So four different groups. So we need to find which carbon is attached to four different groups. So this carbon is attached to same group, so this is wrong. Then this carbon is attached to two hydrogen, so same group, therefore this is wrong. Then this carbon is double bonded, and double bonded carbon is attached to two same groups, that is this double bonded carbon is attached to the same group, therefore this is not the chiral. Then this carbon is chiral, since this carbon is attached to four different groups, so one chiral carbon. Then this is obviously chiral, as it is mentioned. This is also chiral, this is also chiral, since they are mentioned. Then this carbon is also chiral, since it is attached to four different groups and it is not mentioned, so two chiral carbon. Then this carbon is chiral, since this carbon is attached to four different groups, so 3. Then this is not chiral, this is also not chiral because this is attached to two hydrogens. So overall we get 3 chiral carbons, or it can produce 3 optical isomerism. 22. An alkene is reacted with acidified KMnO4. The desired organic product has a relative molecular mass greater than that of the alkene by 34. That means the alkene is reacted with acidified KMnO4, and the alkene, after reaction, the product that is formed has a mass that is greater than 34. That means initially if we consider the mass of an alkene as X, then the final mass that is formed is X plus 34. That means 34 is the extra mass that is being added. So we need to find what condition should be used. So the condition can either be cold dilute acidified KMnO4 or hot concentrated acidified KMnO4. It cannot be cold concentrated or hot dilute. So the condition can either be cold dilute or hot concentrated. Cold dilute or hot concentrated. It cannot either be cold concentrated or hot dilute. So the answer could either be B or C. And among these options, if let's suppose we consider the alkene as ethene, so this is the alkene that is ethene, and if ethene reacts with cold-dilute acid by KMnO4, then the double bond breaks and OH group is attached to both the carbons. So this product is originally formed, and if we consider the product with, if we compare the product with the alkene that is formed, that is, this is the alkene and this is the product. So the product, if you compare both of these two, then the product has these two group as extra. That means these are the extra mass. So what is the total extra mass? Oxygen is 16, that is its MR is 16 and hydrogen is 1. So total 17 plus 17, that is 17 plus 17 is equal to 34. So the mass increases by 34. So the answer is B. And for option C, hot concentrated acid by KMnO4. So hot concentrated acid by KMnO4 usually causes the breaking of the double bond, and as the double bond breaks, so this carbon atom is attached to two hydrogen, so this is converted to carbon dioxide, and the carbon dioxide that is formed, so this is the carbon dioxide that is formed, and what is the MR of carbon dioxide? It is 44. And what is the MR of alkene? The MR of alkene is 12, then 14 plus 14 is equal to 28. So 28 is converted to 44. So what is the decrease in mass? So there is a decrease in mass, but here we have given that there is an increase in mass. Therefore, this option is wrong. So the correct answer is B. 23. The diagram shows a short length of an addition polymer chain. The polymer has a relative molecular mass of approximately 10,000. Approximately how many monomers units are joined together in each polymer molecule? So we need to find how many monomers are joined to this to form this polymer. So we have given the MR of the polymer. Then this is the polymer, and this is the repeat unit. And if we see this structure, then this structure is the same repeat units. So if we break this structure at this point, and if we join this, then this is the monomer that is formed. So this is our monomer, that is this monomer. And for this monomer, what is the MR? So carbon is 12 and hydrogen is 1 and 1. So 14 plus 14, that is 28. So the MR of monomer is 28 and the MR of polymer is 10,000. So 10,000 by 28 gives us a value that is 357.1. 357.1. So this is approximately 360. So the correct answer is B. Question number 24. Lactide is an intermediate in the manufacture of synthetic fiber. Which compound on heating with an acid catalyst can produce lactide? So this is the lactide that is formed, and which compound produces this lactide? So this is an intermediate, and here we have given the structure of lactide. So which compound produces this lactide? So this is the repeat unit of this lactide, and if we just break this repeat unit, so this breaks like this. So this part is same as this part. So this is the repeat unit, and what is the structure of the initial product, initial reactant? So METH, ETH, prop. So this is propanoic acid, that is propanoic acid, CO and OH. So this is propanoic acid, and here there is an O, that means OH. So this OH is on the second carbon. So sorry, this is on the second carbon, OH. So this is METH, ETH propanoic acid, and this is 2-hydroxyl propanoic acid. So the structure is 2-hydroxyl propanoic acid that produces this lactide. So the answer is C. 5. Diols in which both hydroxyl groups are bonded to the same carbon atom can spontaneously eliminate a molecule of water to form a carbonyl compound. So diols, that means diols in which both hydroxyl groups are bonded to the same carbon atom. So the hydroxyl groups are bonded to the same carbon atom. So you have to remember this, that they are bonded to the same carbon atom. Then which compound is hydrolyzed to give a product that gives a positive reaction with 2,4-D NPH? Since it gives a positive result with 2,4-D NPH, so it can either be an aldehyde or a ketone, but not with Fehling's reagent. Since it does not give a positive result with the Fehling's reagent or a Tollens reagent, so this is not an aldehyde, this is a ketone. So the product that is formed is ketone. So we need to find the product that is formed, that is ketone. So for each of these reactions, there is 1,1 dibromopropane. So 1,1 dibromopropane. So METH, ETH propane, and there is 1,1 dibromopropane is hydrolyzed to form the product, that is this product, that is OH, and OH is attached to this carbon atom. So this can be hydrolyzed. So here we have given that the hydroxyl groups are attached to the same carbon atom. Yes, they are attached to the same carbon atom. So they can spontaneously eliminate a molecule of water to form an carbonyl compound. So this molecule eliminates a water. So as it removes a water, so OH is removed from this carbon and H is removed from this part. So here an aldehyde is formed, and since an aldehyde is formed, so the product is not an aldehyde, so the product is ketone, therefore this is wrong. Then for the second option, that is 1,2 dibromopropane. So METH, ETH propane, and there is 1 bromo and 2 bromo. So 1,2 dibromopropane is converted or hydrolyzed to form this. There is Br is replaced by OH, and this is the product. And for this product that is formed, here we have given the diols. That means the hydroxyl that are attached to the same carbon atom, but they are not attached to the same carbon atom. Therefore, this cannot be spontaneously hydrolyzed. Therefore, this option is wrong. Again, 1,3. So 1,3, that means 1,3 dibromopropane. So for 1,3 dibromopropane, METH, ETH propane, 1 bromo and 2 bromo. This is hydrolyzed to form OH. So Br is replaced by OH. So again, here we can see that. So these OH groups are not attached to the same carbon atoms. Therefore, this cannot be hydrolyzed to form a carbonyl compound. Therefore, this option is also wrong. So the correct answer is D. And for this option D, that is 2,2-dibromopropane. So METH, ETH propane, and this is Br and Br. So 2,2-dibromopropane is converted to, that is Br is replaced by OH. So OH, and this is hydrolyzed to form, that is OH is removed from this carbon and hydrogen is removed from this part. So it obviously forms a ketone, that is CO. So this forms a ketone. Therefore, this product is only the ketone. Therefore, the answer is D. Question number 26. X and Y are the reagents required to convert 1 mole propane into butanoic acid. So 1 mole propane is converted to butanoic acid. What are the current identities of X and Y? So what is X and Y? So here we can see that Br is replaced by Cn. So this is nucleophilic substitution reaction. So this is KCN in ethanol, KCN in ethanol. This cannot be ammonia. And let's suppose if the reactant is ammonia, then the product that is formed contains NH2. So this is not ammonia. And this is not HCN. And usually what reaction occurs, that for the reaction of HCN, the COH group reacts with HCN in presence of KCN catalyst to form the product, that is here delta positive carbon. So we do this working at this plus. So COH. So here the carbon is delta positive and oxygen is delta negative. So what occurs that is that CN nucleophile is attached to this carbon, and here the bond is broken. So CO minus and CN H is formed. Then this O minus reacts with hydrogen to form OH. So this is the usually reaction that occurs of HCN in presence of KCN catalyst. But since this is not related to this question, so this option is wrong. So the option can either be B or C. Then for here we can say that CN is converted to carboxylic acid. So this is hydrolysis reaction. So this is an acidic hydrolysis reaction. There is HCl in presence of water converts CN to carboxylic acid. So the correct answer is C. Question number 27. Q is a compound with the molecular formula C4H10O. Q can be oxidized with acidified potassium dichromate. Q cannot be made by reducing carboxylic acid with LiLH4. So that means Q does not produce carboxylic acid. So what is the structure of Q? So this is for option A. that is CH3 COH, then CH2 CH3. So this is the structure of Q, and Q is oxidized with acidified potassium dichromate. So let's oxidize Q. So Q is oxidized to form an ketone. So ketone is formed, and if we convert this ketone, so the product that is formed is ketone. So the product is not carboxylic acid. So this could be the answer. Then for option B, for this reactant, so this is oxidized to form carboxylic acid. This is oxidized to form carboxylic acid, that is COOH. So this is the carboxylic acid that is formed, and this carboxylic acid can be reduced with LiLH4 to form this Q. So this is not the answer because it cannot be carboxylic acid that is converted to Q. Then for option C, here we can see that this carbon is attached to 3 other carbon atom. So this is a tertiary alcohol, and tertiary alcohol cannot be oxidized. Then for option D, again this is oxidized. So CH3 2 CH CH2 COOH. Since this carbon is attached to OH, that is the first carbon atom is attached to OH, so this is converted to carboxylic acid, and this carboxylic acid reacts with LiLH4 to form Q. Therefore this option is also wrong. So the option that is correct is A. 728. A sample of 2.30 gram of ethanol. So ethanol is mixed with an excess of aqueous acidified potassium dichromate. So ethanol reacts with acidified potassium dichromate. The reaction mixture was boiled under reflux for 1 hour. So the reaction mixture is boiled under reflux. That means heat under reflux occurs. So carboxylic acid is formed. The required organic product was collected by distillation. The yield of the product is 60%. So the yield is 60%. Now, as the product is collected by heat under reflux, so obviously it is the product that is formed is carboxylic acid. But instead of reflux, if the product is only collected by heat under distillation, that means heat under distillation, then an aldehyde is formed. But for now, as it is heat under reflux, so carboxylic acid is formed. So this is the overall reaction, and which mass of the product was collected. So we need to find the mass of product. That is the mass. So we have given the mass of the ethanol. So we need to find the number of moles of ethanol. So number of moles is equal to mass in grams by MR, and MR is CH3 is 15 plus CH2 is 14, and OH is 17. So the overall MR that comes to be is 46. So mass in grams by MR is the number of moles of ethanol, and this number of moles is same as the number of moles of ethanoic acid. So we know the number of moles of ethanoic acid. So mass of ethanoic acid is the number of moles into MR. So mass in grams is equal to number of moles and the MR. So what is the MR of ethanoic acid? So CH3 is 15, carbon is 12, oxygen is 16, and OH is 17. So the overall MR that comes to be is 60. So 0.5 into 60. So 0.05 into 60, 0.05 into 60, the answer we get is 3. So the mass is 3 gram. So this is the mass of the product, but here we have given the yield is 60%. That means 60% of the product is formed. So 60% of the mass comes to be 1.8. So 1.8 gram. That means this mass of product that is only formed. So the answer is C. 29. Which compound gives a positive test with alkaline aquacidin and does not show optical isomerism? So as it produces a positive test with alkaline aquacidin, that means it contains CH3CO group or CH3OH group, and it does not show optical isomerism. That means there is no chiral carbon, and chiral carbon is a carbon that is attached to 4 different groups. That means there is no chiral carbon since there is no optical isomer. So CH3COs, so if we just draw the structure, then CH3, CO, then CH2, CH2, OH. So for this option, here we can see that the CH3CO group is present, so it gives a positive result with alkaline aquacidin, and there is no chiral carbon is present. So yes, the option is correct. Then for option B, here we can see that there is no CH3CO or CH3OH group, therefore the option is wrong. Then for option B, C, that is CH3CO, then CH, CH3. So yes, CH3CO group is present, so it gives a positive result with alkyl nicosidine. But here we can see that chiral carbon is present, and this is our chiral carbon that is attached to 4 different groups. Therefore, as it is mentioned that no chiral carbon, therefore this option is wrong. Then again, for option D, here we can see that CH3, then CH3, then OH, then COH group is present. And for this option, here we can see that for this option, here we can see that this is for positive test with alkyl nicosidine. This have to be methyl ketone, that is methyl ketone or methyl hydroxyl group. But here we can see that there is dimethyl hydroxyl group. Therefore, this option is wrong. It have to be a methyl ketone or a methyl hydroxyl group, but there is dimethyl hydroxyl group. Therefore, the more appropriate answer is A. So the option D is correct. The option D is wrong, though it does not show optical isomerism. But since it is dimethyl hydroxyl group, therefore this option is wrong. So the more appropriate answer is A. Question 30. Citral is found in lemongrass oil. It can react to give compound W. So it can react to give compound W. What could compound W be? So first of all, this compound reacts with hydrogen in presence of nickel catalyst. So as it reacts with hydrogen in presence of nickel catalyst, so what occurs there is that the double bond breaks and the hydrogen attached to this carbon atom. So mainly the double bond breaks. So here the double bond breaks and the hydrogen atoms are attached. So here we can see that the double bond breaks. Here also the double bond breaks. And the option D is obviously wrong and C is also wrong. So what occurs mainly is that the hydrogen in presence of nickel catalyst reacts with the double bonded carbon, and so the double bonded carbon, the double bond breaks and the hydrogen atoms are attached. So the double bond breaks, so there must not be any double bond. Then this compound reacts with hot concentrated acetate KMnO4. So hot concentrated acetate KMnO4 usually causes that, since KMnO4 is an oxidizing agent, so it can oxidize the aldehyde to carboxylic acid. So since hot concentrated acetate KMnO4 is an oxidizing agent, so it oxidizes the aldehyde to carboxylic acid. So carboxylic acid is formed. And since there is no double bond present, since the double bonded carbon is attached to hydrogen, so there is no double bond present. But if there is a double bond present, then due to this presence of hot concentrated acetate KMnO4, the double bond breaks. But since there is no double bond, so the correct answer is B.